This is the homework assignment for 3-6 in your algebra textbook. We are starting on number 3. So this dog, represented by W, weighs over 120 pounds, but not more than 130 pounds. We're going to graph the possible values on a number line. So when they say graph, a lot of times we think of our 4-quadrant graphs. But a number line is also a graph. And so we don't know the exact weight of this dog. We just know that it's over 120, meaning it can't be 120. It's more than 120. But it's not more than 130. So it's probably between these. But we also need to notice the wording here. It says not more than 130. So it could be 130. It just says not more than 130. So we're going to have to put 2 spots on our graph, 120 and 130. The area between them, more than 120 and not more than 130, is all of this. Now, because 120 is not included here, it says weighs over, cannot be 120, over. We need to leave this as an open circle. That shows that it is not included. And then it says not more than 130, meaning 130 is a possible answer. So what we're going to do is we are going to actually fill that in, and that is part of the solution set. Okay, number 4, we are going to graph these on a number line. And so when you do this, you don't have to be real fancy with it. We're doing this mixed number, but what I'm going to do is just put a 0 here. And I'm going to put this number right here because it's positive, 2 and 1/5. And so we're supposed to graph x is less than 2 and 1/5. And so what we're going to do is we're going to go ahead and put an open circle here. The only way we close that in is if it's included, and if it's included, it's going to have an equal sign right here. Okay, and it says x is less than. So whenever we're judging this, x could be on the other side as well. So we're going to read it from the x. It's closed towards the x, meaning less than. It's always open towards the bigger one. So x is less than this. So all the numbers that are less than 2 and 1/5 are in this direction. So we're going to shade that way. And you have to put an arrow on the end of it because it means it goes on forever. It doesn't stop right here at whatever value that is where our graph ends. It goes on past what our graph shows. So you need the arrow. So number 5, it doesn't change if it's an x or a y or any letter. We got -3. So again, I'm going to put 0 here, and that means -3 is over here. Y is less than or equal to -3. So again, you read it from the variable. Closed towards the variable, so it's less than. So first of all, we're starting, this is called your boundary point, at -3. Less than means it's going this direction. There's no boundary point on this side, so we need the arrow. And it does have an equal sign, meaning it's included. So we must fill in that circle. So y is less than or equal to. The or equal to means it's part of the solution set, -3. Okay, number 6. Consider the inequality 20 is less than 30, which is true, right? 20 is less than 30. What true inequality results if you multiply both sides of the inequality by the given number? So for A, we're going to multiply both sides by 6. So 6 times 20, that's 120. I multiplied by a positive. We've talked about those rules. So I'm not going to flip this. It stays the same. And if I multiply this by 60, I get 180. And notice that that's still true. 20 is less than 30, and 120 is less than 180. So if you multiply both sides of an inequality by a positive number, it still is true. What about by 1/2? So multiplying this by 1/2, you get half of the number. So you're going to get half of 20 is 10. Half of 30 is 15. Is it still true? 10 is less than 15. Yep, still true. In letter C, this is what they want you to see now. You multiply by a -4. So -4 times this is -80. I'm going to wait on the inequality here for a second. And -4 times 30 is -120. Now, if I keep this the same, it says -80 is less than -120. And if you think about a number line, -80 would be here and -120 would be here. So -20 is actually less. It needs to be closed towards the -120, and therefore that is why the rule exists that when you multiply both sides of an inequality by a negative, we have to flip this. Otherwise, it's not true anymore. So if you multiply or divide both sides by a negative and you don't flip the inequality, you're creating an untrue statement. So every time you multiply or divide by a negative on both sides, you have to flip it just to maintain the fact that it's true. All right, moving on to number 7. We're going to solve the inequality and then check our answer. On these, there's 2 checks to show, so we're going to go over that. So very simple to solve. Just like if it was an equal sign, you're trying to isolate your x. So we're trying to get x by itself. So we are dividing by the number we want to get rid of. Since this is multiplication, we're undoing it with division. And anything divided by itself creates a 1x. And so we want that. Now, we did not do anything with negatives. So our inequality is going to maintain the direction that it's going. And 15 divided by 5 is 3, but this is not 15 divided by 5. It's 5 divided by 15. And so if we tried that on a calculator, 5 divided by 15, we get a nasty decimal. Now this is a decimal we're going to talk about a lot. This is 1/3, and 0.6 repeated is 2/3, and those are decimals we need to recognize. But in this case, we're going to leave it as 5 over 15, but we're going to simplify it. So we can divide both of these numbers by 5, and it gives us 1/3. Real quick, if you want to simplify fractions in your calculator, you bring up your fraction, which is alpha x, put the 5, put the 15, and just hit enter, and it'll simplify it for you and make the 1/3. Okay, so now we have to check this. Okay, this is our answer. There's 2 checks. Check 1, we use an equal sign. We go back to the original, we rewrite it with an equal sign, and we plug in our answer. So 15, and instead of x, we put in 1/3, and that is going to be 5 on this side. And then you run it like a normal check. 15 times 1/3, you can do it in your calculator, is 5. It's like dividing by 3. You get 5 equals 5. Now this check doesn't tell you that this entire answer is true. What it tells you is that 1/3 is the correct boundary point. It's the correct starting point. Okay, from this point, either up or down, this is true. But what we don't know is, did we get the up or the down correct? Is it greater than or should it be less than? It's definitely 1/3, but is it greater than 1/3 or is it less than 1/3? And that's where the check number 2 comes into play. So we are going to go all the way back to the original. We're not going to write an equal sign. We're going to use the inequality. So it's going to be 15 times something. Let's hold on for a second there. Greater than 5. So you rewrite the original. We're going to plug in for x. Now we're not going to use this number. We're going to use a number that's supposedly in our solution set. When I say supposedly, what I mean is we don't know if this is correct yet. That's why we're checking it. But according to this answer, we want to pick a number that's in the solution set. So x is greater than 1/3. You're going to pick any number greater than 1/3. It's your choice. You get to choose. There's no right or wrong way to do it, except we just can't choose a number that's less than 1/3. So don't choose 0, because 0 is not in this solution set. X is greater than 1/3. So I'm going to pick a number greater, like 1. 1 is bigger than 1/3. You want to pick 10, you want to pick 100, you want to pick 47. It doesn't matter as long as it's bigger than 1/3. Now solve this out. 15 times 1 is 15. And is this a true statement now? Is 15 greater than 5? Yes, it is. So both of these checks are right. So not only is the 1/3 correct, check 1 tells me that, but my greater than sign is correct. Check 2 tells me that. If check 2 came out incorrect and it said like 15 is less than 5 or something that wasn't true, that means our greater than or less than sign is pointing the wrong direction. Maybe we forgot to flip it when we divided by a negative, or maybe we flipped it when we shouldn't have. Okay, that happens. So moving on to number 8. Negative 32 is less than 2n. So solving this like we would normally, we're trying to isolate n. Okay, and I am dividing by 2 to do so. Trying to get rid of this. 2 divided by 2 is n. That's a positive number. I know there's a negative here, but the number we divided by on both sides is positive. So there is no change here in the inequality. I get negative 16. Some people like to rewrite this with n on this side. They just get used to that. That's fine. But if you're going to do that, you need to maintain the inequality. So notice that it's open towards n. So if you're going to put the n on this side, it needs to be open towards n. These two things say the same thing. And you read it from the variable. So even if you were looking at this first one, you're still going to read it as n is greater than negative 16, just like this says n is greater than negative 16. They say the same thing. Read it from your variable and judge it based on whether it's open towards it or closed towards it. Since it's open towards your variable here, it's greater than. And your answer, your solution set, are all the numbers greater than negative 16. Okay, so 2 checks here. Check 1. With an equal sign, negative 32 equals 2 times, plug in your number, negative 16. Well, sure enough, you multiply, it's negative 32 on both sides. That means the negative 16 part of our answer is correct. Now we got to check, is our inequality facing the right direction? So check number 2. Pick a number greater than negative 16. That's any positive number. That's 0. If you wanted to, you could pick a negative number that's bigger, but I don't know why you would do that. I'm going to go with 0. So rewriting the original, and you're not putting equals for check 2. You're actually using the inequality because that's what we're trying to judge. 2 times any number that fits the solution set, any number greater than negative 16. So 0 is greater than negative 16. I'm going to plug it in. 2 times 0 is 0. Bring it down, and now look at this and make sure it makes sense. Is negative 32 less than 0? Yes. That's good. My check works. So therefore, my answer is completely correct. Number 9. Okay, we got a little bit of a fraction. That's okay. We know how to solve these. So we're going to multiply by the reciprocal to clear it out. So we are multiplying by 5/4, or you could divide by 4/5. We've talked about how that works as well. So you get 20, 20, so you get 1, so you have y. We have not multiplied by a negative, so the inequality faces the same direction. And now you're going to do 20 times 5/4. So 20 times alpha x 5/4. And it's 25. So we believe the answer is y is less than or equal to 25. Let's do the check and find out if we're right. So check number 1, rewriting it from the original, 4/5 times the number you got, 25. Use equal sign, 20. And now make sure it actually works. So let's plug it in. 4/5 times 25. You do get 20. So 20 equals 20. Check 1 works. So we know 25 is the correct number now. Is the less than sign correct? So here is check 2. Going back to the original, 4/5 times a number. We'll choose that number in a second. Using the inequality for check number 2, we have to pick a number in this solution set. It says y is less than 25. So pick a number less than 25. Again, I'm going to choose 0. I don't even need my calculator because I know 0 times anything is 0. And now I judge this. Is 0 less than 20? Yes, it is. So I'm good to go. Number 10. So we've got negative 3/2 z less than or equal to 1. So to solve this, we need to multiply by the reciprocal, which is negative 2/3. Flip it upside down. Negative 2/3. So we're going to end up with a positive, negative times a negative, positive 6/6, which leaves me a 1z. But this is the special case. I have multiplied both sides of this inequality by a negative. Just like we did up here, we had to flip that sign to keep this a true statement. So we need to now flip our inequality the other direction because we multiplied both sides of that inequality by a negative. And then 1 times anything is just the number, so we get negative 2/3. And so we believe this is the answer. Z is greater than or equal to negative 2/3. So let's check it. Check 1, back to the original. Negative 3/2 times z, which we believe is negative 2/3, equals 1. Well, sure enough, right? We don't even have to plug this in the calculator. These are reciprocals. Of course they equal 1. 6 on top, 6 on the bottom. Negative times a negative is a positive. We get 1 equals 1, and that's good. So our negative 2/3 part of this answer is good. Check number 2. We got to go back and check this sign. So now we don't have to use fractions. We're going to pick a number greater than negative 2/3. Pick a nice, easy whole number to do that. So negative 3/2 times z, we'll choose that in a second, less than or equal to 1. Notice the sign is pointing the way it originally was, not this way. Back to the original. Now, it says Z is greater than negative 2/3. Well, what's a number that's greater than every negative? 0. So if 0 is an option, use it. Now, some people start using 0 all the time. I've seen that mistake. 0 is not always in your solution set, so you can't always use it. But if it's in your solution set, use it, because it's easy. Anything times 0 is 0. Is 0 less than 1? Yes, it is. I know my answer is good. Number 11, negative 3a less than or equal to negative 6. So to solve this, I want to get a by itself. I have to divide by this number that's attached to it. I'm dividing by negative 3. Dividing by a negative means I have to flip it. Whether you're multiplying by a negative or dividing by a negative on both sides, you must flip it. So now it's open towards the a instead of closed towards the a. These have canceled. Negative 3 divided by negative 3 is 1, which we don't write. A negative divided by negative is a positive, and 6 divided by 3 is 2. So we believe it's a is greater than or equal to 2. So check 1. Change this to an equal sign and plug in your answer. So plugging in 2, is this true? Negative 6 equals negative 6. Yes, it is. So I know 2 is the right number. Now I got to check, is this pointing in the right direction? So again, back to the original, negative 3 times something less than or equal to negative 6. Keep the sign pointing the original way. Pick a number that's greater than 2. So here's a great example where you can't use 0. 0 is not greater than 2, so you can't pick that. So let's go ahead and pick 10. Easy one. Negative 3 times 10 is negative 30. And now read it carefully. Is negative 30 less than negative 6? It is. So our check works, and I know that this entire answer is good. So on to number 12. 7b is greater than or equal to 6. Very similar to the ones we've just done. This is multiplication. We're trying to isolate the b, so we're going to divide by 7. 7 divided by 7 is 1. Got to do it on both sides, and since it's a positive, we are going to keep it facing the same direction. 6 divided by 7 is not going to be a nice number. Okay, so we're not going to use the decimal version. We're going to leave it as a fraction, and it is already simplified, so we're just going to leave it as 6/7. So we're going to say b is greater than or equal to 6/7. So 2 checks. Check 1 with an equal sign. 7 times 6/7 equals 6. Test it out. Don't just assume that it works. 7 times 6/7 is 6. So 6 equals 6. That check is right. So 6/7 is the correct boundary point. Now, is it supposed to be less than and not supposed to be greater than? Let's check that out. Check number 2. So we are going to keep this as a greater than, just like the original, and it's now 7 times a number we'll choose, and 6 is still there. So we need a number that's greater than 6/7, positive 6/7. So we can't use 0. So you can use any number you want. I'm just going to go ahead and use 1. 1 is bigger than any fraction. Or how about, let's just choose a really big number like 10. Okay, it's bigger than 6/7, right? So it works. So we end up with 70 greater than or equal to 6. That's true. And so I know this is good. All right, we skipped all the way to number 16 after that. So at 16, we're going to read the problem, some kind of word problem. 2 things we're going to do. We're going to write an inequality, and then we're going to solve it. So 16. An engineer is designing a rectangular parking lot. That's important. We know rectangles pretty well. Very easy to find the area and perimeter of a rectangle. It is going to be 75 feet wide. So let's go ahead and label that. And it doesn't matter if you put the 75 here or here. According to the city building code, the area of the lot can be at most, so no bigger. It can be this number, but it cannot be bigger than 6,250 square feet. So they're talking about all of this in here. And that is not the perimeter. That's not the distance around the outside. That is the area. So how do we find the area of a rectangle? It's base times height, or length times width, however you want to write it. Base times height is fine as well. They're both pretty much the same thing here for a rectangle. And so what is the allowable length of the lot? So we need to come up with a length. I'm going to use the L for length. So I'm going to go ahead and use this formula, but we're not going to use an equal sign because it doesn't have to be exactly a certain number. But it cannot be more than 6,250. So the area has to be less than this, or it can equal that. So I know I've got a length of L times 75. So if I had the length, when I multiply them together, this area has to be less than or equal to 6,250. So this is your initial equation here. Now, you could put it as 75 times L. It doesn't matter. You could use a different letter than L. That's fine. But it's 75 times your variable. That amount has to be less than, so it's closed towards that amount. Even if you put it on the other side, it has to be closed towards that amount. This represents the area, 75 times this. That area has to be less than or equal to 6,250. So we're going to go ahead and solve that now. That was part A. Part B is to actually solve it. So very simple. We're trying to isolate that variable, right? So we're going to divide by 75. And now L is isolated. This wasn't a negative, so I'm going to maintain the direction of my inequality. And what happens when I actually divide this? Let's see. 6250 divided by 75. Is that a nice number? No, it's not. Now, we should know that this is 1/3. When I see 3 repeated, it's 1/3. So it's 83 and 1/3. So you could technically use that as your answer. That's fine. In fact, I will use that as my answer, 83 and 1/3, because I know that 3 repeated is 1/3. So that's one way to write it. But let's say you didn't know that. We then need to leave this as a fraction, but this is definitely not a simplified fraction. So we can leave our answer as a fraction. We're not going to use the decimal version of 0.3 repeated. So using the calculator to help you simplify, 6250 on top, 75 on the bottom, and just hit enter, and it will fully simplify it, 250 over 3. And if you go back and look at what it was, how did they get to here? They must have divided by 25 because this became a 3. So if you divided the top and bottom by 25, you'd get this. But if you have a calculator, you don't have to figure that out yourself. And this is, of course, the way the answer was written in the book. But if you gave me this answer, perfectly fine. But please do not give a decimal answer. That must be rounded. We're not going for that. All right, 17. We have a concert hall. It needs to seat at least. So this many people or more. Each row will have 80 seats, and how many rows of seats? So again, we're probably looking at a rectangle here. And every row across, we've got rows of seats, rows of seats, rows of seats. This way across is 80. But how many of these rows do we have to have for a total of, which is the area again, 2,200 people? So this would be represented by the number of rows here. I'm going to use R. So again, the area, which is the number of people here, comes from base times height. So if I take 80 times R, the length times the width, the base times the height, I'm comparing it to the number 2,200. So let's talk about the inequality. It says that this concert hall needs to seat at least. So this number, so don't look at this one, this number, when I multiply this, has to be bigger than or equal to 2,200 because it says at least. It doesn't say no more than, it says at least. So it's allowed to be bigger, but it also can equal it. So this is what my inequality is going to look like. Open towards this, saying that this number, after I know what R is and it's multiplied by 80, is going to be bigger than this or equal to it. So at least 2,200. So that's part A. And now we're just going to go ahead and solve it for part B. So for part B, divide by 80. I'm left with R. I do not flip anything because there wasn't a negative. And 2,200 divided by, 2,200 divided by 80 is a nice decimal. So again, you're allowed to give me a decimal if you didn't have to round it. 27.5 is the exact answer. And that's perfect. And now, if you're actually going to put this in, like, let's say a sentence and answer this question, you wouldn't say at least 27.5 rows, most likely, because you're probably not going to put a half a row. Although I guess you could. So that would be fine. But you would say if you had to put full rows, since this has to be greater than 27.5 or equal to, if we're going to say that it can't equal this because there's no half a row, then you would say 28 or more rows. All right, and we are skipping to 19 and 20, and then we're done. So 19, we're going to solve this equation. We've got some simplifying to do, some distributing. So I've got two sides of my equal sign. The right side is simplified, so I'm going to go ahead and just distribute and simplify this side. So this plus 7 is going to hang out here for a second. So is the equal 39. I will combine the 7 with something over here if I can after I've distributed. So I get negative 12x. A negative times a negative is a positive. And 4 times 1.5 is 6. You can do that in the calculator if you need to. So now, my like terms are the 6 and the 7 because they do not have variables on them. So you can go ahead and put them together. That's 13. So it's negative 12x plus 13 equals 39. And now we've got it in that nice two-step standard form. So we can just go ahead and try and isolate the x at this point. There's no more like terms to combine, and you can't combine across the equal sign. So we're going to start eliminating things so that x is by itself and I have an answer. It doesn't say that I have to check, so we're just going to go ahead and solve this. So we start with the number that isn't attached. It's a plus 13, so we're going to minus it, which gets it to 0, and it goes away. We're left with negative 12x. And over here we have 26. So then we're going to divide by negative 12. Negative 12 divided by negative 12 is a 1x. That's good. And if we go ahead and divide 26 by negative 12, we don't get a nice decimal. So we are going to leave this as a fraction. I look at that and I can see that that can simplify. I have two even numbers here, so I can divide them by 2. And in this case, that's all I can divide them by. But sometimes there's other numbers as well. So let's go ahead and practice using the calculator. We got 26 on top. We have negative 12 on the bottom. Hit enter and it'll simplify it, and it's negative 13 over 6, which is the answer that you would find in the textbook. All right, and I'm going to go ahead and squeeze number 20 in right here. So the negative 19 is going to tag along for a while as we simplify this side. Two things to distribute, and I need to maintain the fact that this is a negative when I go do that. So 2 times a is 2a, 2 times 5 is 10. Negative 3 times 5 is negative 15. Negative 3 times 1/2, do it in the calculator if you have to. 3 times 1/2 is 3/2. And this was a negative times a positive, so this is a negative 3/2 a. Okay, we need to combine like terms now. The a's can go together, and the 10 and the 15 can go together. So starting with the 10 and the 15, that's a positive 10 and a negative 15, or 10 minus 15. That's negative 5. And I like to put that there and then the variable up front. You don't have to do that. And then you're combining your a's. It's a 2 minus 3/2 a. So just do it in your calculator. 2 minus 3/2. Now, I know you don't have this calculator at home, but you should be able to use your calculator with the fractions to get this. And you end up with 1/2 here. So I have 1/2 a minus 5. So even though that's a fraction, I'm in good form here. All I have to do is add 5 to both sides. I'm left with 1/2 a. And this gets me negative 14. Now all I got to do is multiply by the reciprocal. And the reciprocal of 1/2 is 2 over 1, which is just 2. So I get 2 over 2 over here, which is the whole point. I get a 1a. And this is just like multiplying by 2. So this is negative 28. And I'm done.